Judy.
Hi, this is Shiva from Merit Campus, and today we are going to discuss about the weekend hack of 12th January 2013. One of the problem of weekend hack 12th Jan 2013 was to find if a word is present in a character matrix in any direction. So if we have a character matrix like this, we have to find if a word, given search word, is present in this matrix. It could be in any direction. It could be in horizontal direction or vertical, upward diagonal, downward diagonal, and their opposite directions as well. So here, if you see top is present here like this, and pot is also present, but it is in the reverse direction, horizontal reverse direction. And if you have mat here, mat is not there in this character matrix, whereas east is present in downward diagonal direction. E is here, A is here, S is there, and T is there, so it is true. And then you have test is TEST, so it is there in reverse downward diagonal direction. And ant is there in vertical direction, and 10 is there in reverse vertical direction. And similarly merit is there in reverse downward diagonal direction. And then you have Ravan, which is there in upward diagonal direction. So it could be in any of those 8 directions. And here we are given with a character array or matrix, and then you have to write code here to find if a word is present in the matrix. The search word is passed here, and then there is more place to write any additional methods if required. Before we go to see how to solve this, I assume that you know little bit of arrays, two-dimensional arrays, and you also know how to use for loops. And I also assume that you know little bit of Eclipse and see how to write code in Eclipse and how to compile it. With this background, let's start and see how we could solve this problem. What I have done here is copied the code from the site, the weekend hack code, and I have put it in this Eclipse, and then I'm trying to run it. So first what we'll do is we'll see if we can find this cat. Cat, as you know, is there in reverse diagonal order. So but since it will become complicated, what I'll suggest is let's take a simpler example, and let's see if we can find mass in the character array. So for that, what I'll do is this is checking reverse diagonal. So before that, let's check if we can find the horizontal words. Checking horizontal. So mass is present or not. We'll write that. Now if I just run this program, it will print mass is present is false, cat is present is false, since we haven't written any code. In order to find if the mass is there or not, first of all we need to find if the first character of the search word is present or not. So for that, what I will do is in this method, let me just declare a return variable, and let me just call it result equal to true, and return result. This is a good idea to create the return variable as result, so that we know what we are returning from this particular method. Then what we'll do is we'll go through each and every row. First of all, we'll go through each and every row, and then in that row we'll search for each and every column or character to see if the first letter M is present in this particular matrix. For that, I'll create one more variable, char first char equal to search word dot char out of 0. Then Then I'll say for int row equal to 0, the regular thing. What I have done is I have simply created two for loops to go through the two-dimensional array. First for loop is for going through each and every row, and the second for loop is going through each and every column. If at all the matrix of row is matching with our first character, then we know we found the first character. But finding first character itself is not sufficient. Then we have to match the other characters are present or not. For that, what I'll do is I'll create two more variables called int search row. I'll initialize this to row, and then we have int search column. I'll initialize this to column. What we'll do here is a reverse approach. First of all, let create a variable called all characters found. By default we'll call it as true. If then we'll go in a for loop whenever if we don't find it, then we'll make it as false. This way we'll do a reverse. First of all, we'll assume it is true. We'll go through the for loop. Whenever it doesn't match, then we'll say as false. For this I have to go through each and every character of the word. So first for int char index equal to 0, char index less than search word dot length, char index plus plus. So what we know is we have to find the if the word is present horizontally. If it means horizontally, the row will not change. The row index, whatever the search row, right, will not change. The search row will be same, but the column will keep on changing. Here the row is row index is 2 and the column index is 1, but the column index needs to keep on changing. So since we want to find it horizontally. So what I will do is since we want the column to increment for every character, I will simply say search column plus plus. So whenever char index changes or whenever we are progressing to the next character, we want to change the column index. So if the column index is 1 here, for the second character we want to compare with the column index as 2, and similarly for this column index as 3. So that is how we'll do it. What then we have to do is, if at all we don't match, say first m is at char index is 0, but column index in the char array is char matrix is 1. So 0 and 1 match. Then you will see if A and A match and S match. So search column defines the column index starting from here, whereas char index tells you which character in this particular word. As I said earlier, we will do a negative thing here. So first of all, we will assume that all characters found is true, and then if we don't find it, then we will make it as false. So if matrix of search row and search column not equal to the search word dot char of char index, if they are not equal, then we will simply say all characters found equal to false. This will go and check if this will go and check every character in the word. Whenever if it doesn't match, we'll simply say as false. Since we are doing this for loop, if at all to start with, even though we started as true, so if any one of them doesn't match, it will simply say all characters found is false. If at all we don't find it, then there is nothing else to do, because we have to go check for this character m anywhere else in the character matrix. But if all characters are found, which means the word which we are searching for is found, then we could simply say word is present in the matrix. So if all characters is found, then we have to simply say result equal to true and then break. Since if we found the word, then we can simply return get out of the for loop. But there are two problems here. One is the result itself, initially we have made it as true, so I'll make it as false. So by default it is false, If at all we find that word anywhere in the matrix, then we'll make it as true. And the other problem here is break. The break will only break for one for loop. Since the break, we have to break two of them, what I'll do is I'll simply say create one more label called outer here, and I will say break outer, so that it goes out of the outer for loop. Let me just run this and see. So it says mass is present is true, because mass is present here, so it will say mass is present is true. But let's see if it will also say false if the word is not present. So let me try mat. So mat is present or not, let's see. So I'll say mass is present, I'm searching for mass, then I'm searching for mat. So if it says mass is present is true and mat is present is false. So till now it seems to be working fine. What I will do is let me see if I can find one more word which is bigger than the index. So if instead of MAS I'll say mass, I'll see if mass is present or not. So if I run this, now I'm getting an array index out of bounds exception. Why is this? This is because we are starting with character M, and that is here, and then we are going column by column. So it went here, it went here, it went here. When it is not matching S, it is trying to match with the character after S here. But obviously there is no character here, so it is giving an array index out of bounds exception. To avoid this, what we'll have to do is, whenever we are comparing this, we should also check that the index which we are searching for should be valid. So for that, what I'll do is, if search row is less than matrix.length and search column is also less than the matrix of row.length, then only it is valid. So what we'll do is here, since we are checking for negative thing here, what I will do is, if at all the character index is invalid, then we will say all characters found is false. So that is what I will put here. If search row is greater than or equal to matrix.length, or search column is greater than or equal to matrix of search row dot length, then we will say all characters found is false, which means we are, since the index which we are looking for is greater than the length, which means that the whole word is not present, so it will fail. So that is why we will put these two conditions as well. So if at all the index is invalid, then we will simply say the all characters found is false. Let's run this and see. And as you can see, now there is no exception, but it properly gives you mass is present as false. What we have done till now is we have checked if various words are present horizontally or not. And for that, as you see, we found if the first character is present. Then we created other indices to go through each and every character in the search word and checked if the character doesn't match or if the index itself is invalid, then we are simply saying all characters found is false. And only if all characters found is true after the for loop, then we are saying result equal to true and breaking the outer for loop here. Next, what we have to do is we have to find if a word is present vertically. So for that, let me just put some comments here. I'll say searching for horizontal word. After this, we have to do for vertical. So for that, what I'll do is I'll just take this code and copy it here, and I'll say search for vertical word, and I'll initialize this search row and search column to row and column again, since here search column is getting changed. And also all characters found also I'm just reinitializing it to true. since the rows, the variables are already declared here, and since it is in the same scope, the variables are said to be duplicates. That is why I removed the declaration part before, or the data type part here. But the only difference between vertical word and horizontal word is, for horizontal word the row remains the same but the column keeps on increasing, whereas for the vertical word the column remains the same but the row keeps on increasing. So what we have to do is, earlier we were changing the search column plus plus, but now we'll simply say search row plus plus. Here let's put one more checking vertical. I'll check if the word STM is present in the char matrix. STM is present or not. So what we have done here, first of all we are checking for horizontal. If it is not there, we are checking for vertical. If it is there, then as usual we are saying result equal to true and break is outer. And STM is the word which you are looking for, that is present vertically here. Let's run this. As you can see, STM is present is true, since we have put the check here accordingly. Let's put two more vertical checks to see if it is not working. So instead of STM, I'll say if ATM is present or not. ATM should not be present. So if I just run this, ATM is present is false, STM is present is true. And similarly what we'll also check is if at all it goes out of bounds, right? If I try searching for score, if I try searching for score, then score should not be present. At the same time, we should also should not get any array index out of bounds exception. Although SC is present, since ORE is not present, it should say it is not present and simply give us false, and it should also not give any array index out of bounds exception. So that is how we have done till now horizontal and vertical word searching. Although we have got the horizontal and vertical word search working, the problem here with this code is duplicate code. There is this code which is approximately 15 lines, which is repeated for horizontal and vertical. In future, if we have to do the same check for say diagonal, something like you want to go from T and go diagonal, then you have to put one more thing like that. And if it is if you have to do reverse diagonal or downward diagonal, then again one more 15 lines of code. Then you have to do something for reverse as well. So this is lots of duplicate code here. To start with, let's see, whenever we find duplicate code, first thing we have to identify is what is that one thing or two things which are different between these two code. So here there is this lines of code and there is this lines of code. The only difference is here we are saying search column plus plus, here we have search row plus plus. So here we are changing column because we are checking for horizontal. Here we are changing the row since we are checking for vertical. So this we could have avoided, or we could remove this duplicate code if we put something called increments. So if we have created two increments, one for row increment and one for character increment, say for here row increment, when we are checking for horizontal, the row does not change, so row increment will be 0, whereas column increment will be 1 because we want to increment this column by 1. So what I will do is, instead of search column plus plus, what I will do is search column plus equal to column increment. And similarly search row also, I will say search row plus equal to row increment. Since the row increment is given as 0, row really doesn't change because row increment is 0. Whereas column increment is, since it is 1, so it keeps on going 1 character by 1 character. The other thing, but when you are checking for the vertical word, row should go 1 by 1, so row increment will be 1, whereas column increment will be 0. Column we don't want to change. So this is what we have to do. So here we have instead of search row plus plus, I'll say search row plus equal to row increment, and search column plus equal to column increment. Since column increment we have given as 0 here for when you are checking for vertical word, so column increment is 0, so search column will not change, whereas row increment is 1, so search row will change. So, whereas here row increment is 0 and column increment is 1 when you are checking for horizontal word. So if you really look at it, except for this row increment and column increment, the rest of the code is exactly the same, this code and this code, and how we initialize this. So if we created a method, and for one thing we pass row increment as 0 and column increment as 1, for the other thing we will say row increment as 1 and the column increment as 0. So what I will do is I'll create a method per se for that particular these two code. What I will call that as is search. So what I have done here is I created a method, basically called it is word present, and for this guy I'm passing the matrix and the search word, but I'm giving it the row at which it has to start and column which it has to start, and also the increment, row increment and column increment. And this code is what we have got from the method here. That method, that code from here, I moved it into use row word present, and then I removed it here and I simply said is word present. I'm passing the matrix search word and the row and column, and the important things here is row increment and column increment. For horizontal, I'm saying row increment is 0, column increment is 1, whereas vertical, I'm calling it as row increment as 1 and column index as column increment as 0. Let's see if it works fine. As you can see here, mass is present is true, mat is so it seems, and all the things seem to be working fine. So by creating this method, we have drastically reduced the code size. Now what we have to do, we have done horizontal and vertical. So let's try next the diagonal. Let's try if we can find the downward diagonal word. So for example, TAC is in downward diagonal direction. Let's see if we can find that gap. So what I have done is I have changed the code. I added for the downward diagonal word. As you know, if it is downward diagonals, the column index should increase by 1, whereas row index should also increase by 1. So it's since downward diagonal, CMZ is in downward diagonal word. So that's what I put here, CMZ, and let's see if CMZ gets printed. So when I run this, CMZ is present. Similarly, let's put the other checks as well for downward diagonal. What I have done is I have put additional checks for TAT and tattoo. TAT is not present here, so it should be false, and similarly tattoo is also not present. At the same time, we should not get any array index out of bounds exception. Let's run this, and as you can see here, we have TAT CMZ is present is true since CMZ is there, whereas TAT is not present, and similarly tattoo is also not present. What I have done next is since we have completed checking downward diagonal, I'll see if we could do checking upward diagonal. What I have done is I have put mad, ma, and after. Mad should be present, MAD is there, whereas ma, MAA is not present. Similarly, after, AFTR. So after should also is not present, but at the same time it should not throw any array index out of bounds exception. So let's see if it works fine or not. Here I have also added the code for upward diagonal. For upward diagonal, the column index will row index will keep on reducing, upward diagonal, and but the column index will keep on increasing. So what I have to do is -1 and 1. So row index will keep on increasing, whereas column index will keep on increasing, whereas row index will keep on decreasing for upward diagonal. So let's run this. I get an array index out of bounds exception, and the value here it shows is -1, because when we are reducing the column, when you are reducing the row one by one, what could happen is row could become -1, and as you know, the indices are only valid from 0 to the length of the array. Since -1 is invalid, it is giving an array index out of bounds exception. So what we will do is, since the array index is getting less than 0, here we are only checking for the greater than. If at all the array index is greater than matrix dot length, we are doing it, but we are not checking for the negative thing. So what I will do, I will simply say such row less than 0, if at all such row is less than 0, or such column is also less than 0. If any one of them is less than 0, which means it is has gone out of the matrix dimensions, so all characters found should be false. So let's run this. So as you can see, now it doesn't throw any array index out of bounds exception, but it will simply print after is present is false. With this we are almost there, but not completely there, because till now we had been only doing checks with incrementing. Say for example, mass is horizontal, which is going like this, and whereas say for example STM is going from top to bottom, and similarly CMZ is going from bottom to top, but it is in the downward diagonal, and similarly upward diagonal. But we also need to handle bidirectional, so it has to be reverse as well. So if it is something is present in the reverse direction, say for example FAT should also be found for a horizontal thing. So let's see if we can change the code accordingly for it to work bidirectional. One thing you have to notice is, when we are doing horizontal, we said column index will increase by 1. So if at all it starts here, it will go 1 1 1. So it is incrementing by 1. If you want to do the reverse search, then you have to basically row should be same as it is, but whereas column increment should be -1. So what we have to check is if it will so column increment, instead of 1 we will make it -1 and see. So what I'll do is I'll change this, and I'll put is word present of the same thing, but instead of G1 I'll make it as -1. So this will search for horizontal word both directions. So it will search either in forward direction or in the reverse direction, from left to right or right to left. I put in a check for FAT to see if FAT is present in the reverse horizontal direction. I changed the code here as you have discussed. I put instead of 1 column increment, I made it as -1. So let's run this. So as you can see here, FAT is present is true is printed. So FAT, not only the forward direction, in the reverse direction also it is able to find it. So similarly we have to make the changes for all the reverse directions. Let me just do it. What I have done is I have put the reverse for each and everything. So if it was 0 1, I made it 0 -1. If it was 1 0, I made it -1 0. And if it was 1 1, I made it -1 -1. If it was -1 1, I made it 1 and -1. And what I have also done is I have also uncommented this cat is present, which is checking for reverse directional thing. So cat is present is true, is also printing as true. Let's see if it works. So as you can see, cat is present is true, and the other checks whatever we are doing. Mass is present, mass is false, fat is true, esteem is true, and the other things seem to be working fine. What I have done further is, since there were like multiple if conditions and result equal to true breakouter for horizontal, vertical, downward diagonal and upward diagonal, what I have done is I have created a little array for increments. And for horizontal, we know 0 is the row increment, column increment is 1. For vertical, row increment is 1 and column increment is 0. For downward diagonal, it's 1 1, and for upward diagonal, it's 1 minus 1. So instead of putting it in 4 checks, what I have done is I created an increments array like this. Whereas first it's a 2-dimensional array, and in every one array you have 0 and 1. First represents the row increment, whereas the second one represents the column increment. So then here what I have done is I put a for loop for each loop, which basically goes through increments. 2-dimensional array, and for every direction you will get 1-dimensional array, and the first index will be the row index and the second index will be the column index. And we also know that since it is for the reverse direction, you just have to negate it. So if it was 1, you have to make it minus 1. If it was 0, you have to make it minus 0, which will basically become 0 again. And if it was minus 1, you have to make it 1. So that way you are checking for the reverse as well. So this will further reduce the code. Let's see if it works fine. Now I run this, and I see that all the checks seems to be working fine. Next we'll copy this into the site and see if all the tests pass there. What I have done is I have copied that code from Eclipse to the site here, and I copied the method section in the methods box, and let me just try answer. So it's testing and registering your answer. If it passes, then whatever we were trying to do is good. So it seems it's passing successfully. So the requirements, all the requirements of like whatever different matrices seem to have passed. Thank you for watching this video.